This is Britt Caswell with another example video. In today's video, I am covering example 4 from section 5-4 in the SavvasRealize Algebra 2 textbook. The goal of today's video is to solve equations with rational exponents. This just looks a little small on my second monitor, so I'm just making it bigger. So this one is asking, what are the solutions to this equation? So a thing to remember, I have a couple things I want you to remember. The first is the product of powers rule. Remember, the product of powers, the power of power rule. So the power of a power rule says that if you have something raised to an exponent that you then raise to another exponent, you can multiply those exponents. I also need you to remember that if you have a fraction that you multiply times its reciprocal, which is where you flip the fraction upside down, what happens is you get the same number over itself, which is just 1. And also remember that any term to the first power is just equal to that term. Alright, so using those three facts, that's how we deal with solving equations with rational exponents. Okay? Just like Coco says, remember me, okay? So here we go. So to get rid of this rational exponent, what I'm going to do is I'm going to raise each side of the equation to its reciprocal. So I'm going to raise it to the 2/5. So what that does is that eliminates all this junk here on the left, like with the weird powers. So the left-hand side of my equation turns into x squared plus 5x plus 5. Now on the right, here's another thing I want you to remember. 1 to any exponent is equal to 1. Because 1 squared is 1, 1 divided by 1 is 1. Okay, 1 to any power is 1. And that's glorious. Because 1 to the 2/5, it's 1. That's right. So now we have a situation here where we have a quadratic term and a linear term. So in order to simplify, I'm going to have to use one of my quadratic rules. Okay, I can factor, complete the square, quadratic formula. And in order to do that, we have to have our equation set equal to 0. So this 1 has got to go. I'm subtracting it from each side. So the left-hand side of my equation turns into x squared plus 5x plus 4, and the right-hand side turns into a 0. Now, lo and behold, this thing is factorable. So let's go ahead and let's do that. So I know I have an x and an x. My first sign falls down, and in order to get a plus 4, my signs have to match. What multiplies to make 4? That adds to make 5. That's 4 and 1. So my possible solutions that are in my little pool are -4 and -1. And those are what we need to check. And I know y'all hate check steps. Just remember the general rule of you need to check yourself or you will wreck yourself. So here I'm just taking that -4 and I'm just plugging it into the original equation. Alright, so kind of cleaning up these parentheses a little bit. -4 squared is 16. 5 times -4 is -20. Alright, so 16 minus 20 is -4. Plus 5 is 1. And 1 to any power is 1. So -4 is certainly a solution. Alright, and then I'm also going to check with -1. So I have -1 squared, 5 and -1. And this gets a little ugly sometimes, right? Just don't lose track of your parentheses and you should be okay. So cleaning up some of these bigger parentheses, Negative 1 squared is 1. 5 times negative 1 is negative 5. So the negative 5 and the positive 5 cancel out, leaving you with just the 1. And 1 to any power is 1, so negative 1 is also a solution. All right, so let's just walk through our steps what we did real quick. All right, so step 1, make sure that the thing with the funky exponent is by itself. Then you raise it to its reciprocal power. Get all of your terms to one side and either factor or complete the square. Okay, let's do it again. Now in this case, that's a little ugly, isn't it? So I have a fractional exponent and a whole number exponent, and we're not going to freak out, okay? I'm still going to raise to the reciprocal function for that fraction because it's the ugly one. All right, so I'm going to go ahead and raise both sides of this equation to the 2/3 power. So let's look at what happens. On the left-hand side, those ugly fractions cancel out, leaving me with x plus 18. And on the right-hand side, 3 times 2/3 is just 2. So this turns into x minus 2 squared. So now there is no ugly fraction to have to deal with. Now, I do need to get rid of that square, but if I took the square root, I'd be back in the situation of having an ugly radical. So what I'm going to do is I'm just going to take some scratch paper to the side, and I'm going to actually square that x minus 2. Okay? So I'm going to take x and times it to each thing. I get x squared minus 2x. And then I'm going to take negative 2 and times it to each thing. So negative 2 times x is negative 2x. And negative 2 times negative 2 is a positive 4. And collect those like terms. So that is what becomes of the right-hand side of our equation. Now, again, I have a quadratic and a linear term, so I need to be able to work my quadratics mojo on it. So I need the equation set equal to 0, so I'm going to subtract x from each side and subtract 18 from each side. That way this left-hand side becomes a 0. Now the right-hand side, negative 4 minus x is negative 5x, and 4 minus 18 is negative 14, and that is factorable. So if I set an x and an x, I'm going to go ahead and drop down that 5, or that negative, sorry. And to get a negative 14, your signs must be opposites. What multiplies to make 14? That subtracts to make 5. That's 7 and 2. So those are going to be the answers that I check, is the 7 from here and the negative 2 from here. All right, so I'm going to start with the 7. So I have 7 plus 18 to the 3 halves equals 7 minus 2 cubed. So 7 and 18 makes 25, and 7 minus 2 makes 5. Now the trick with these fractional exponents is I usually do whatever root is on the bottom and then raise it to that exponent. So like the square root of 25 is 5, and if I cube it, I get 125. And here, 5 cubed is 125. All right, so x equals 7 is a solution. All right, so now I'm going to do that same thing, but now with negative 2. So I have negative 2 plus 18 to the 3 halves equals negative 2 times, or minus 2 cubed. So on the left, negative 2 and 18 make 16. And on the right, negative 2 and negative 2 is a negative 4. And I'm doing that same trick I did up here at the 25, okay? I'm going to square, or take the square root, which is 4, and cube it, which is 64. And then here, negative 4 cubed is negative 64. And those are not equivalent. So That one is extraneous. So the only solution I get here is x equals 7. Let's go ahead and try another one. So these ones get a little bit longer, right? If you notice, I had to use a whole slide instead of a half. So again, we want to get this ugly grouping symbol of stuff by itself. So first I need to get rid of the 14, which I'm doing by just, oops, I don't even know where 18 came from, but I'm going to add 14 to each side. So my left-hand side, I get x squared minus 3x minus 6 to the 3 halves. And on the right-hand side, negative 6 and 14 makes 8. So now to get rid of that 3 halves, I'm going to raise each side to the 2/3. So my left-hand side, these fractions cancel out, right? So I get x squared minus 3x minus 6. And on the right-hand side, the cube root of 8 is 2. And if I square that, I get 4. So I have a square term, I have a linear term. You guys know I need that set equal to 0 so that I can solve my quadratic. So I get x squared minus 3x minus 10 is equal to 0, which is factorable. So here I'm setting up my double bubbles. My minus falls down. To get a negative 10, I need opposite signs. What multiplies to make 10? That subtracts to make 3. That's 5 and 2. And if I set each set of parentheses equal to 0, my answers that I need to check are 5 and negative 2. So if I plug in 5, whew, this is a long problem, y'all. But you know, it's good to have long problems like this because as you move up in math, they stay really long. Okay, so it's good to practice and kind of work through the frustration. Okay, so here 5 squared is 25, 3 times 5 is 15. 25 minus 15 is 10, minus 6 is 4. So the square root of 4 is 2, and if you cube it, you get 8. Alrighty, so 5 is certainly a solution. Now we're going to check with the negative 2. I should have written smaller in my check step, but that's okay. That's alright. The biggest thing that I learned while solving problems like this was actually to write bigger. Because what I noticed was I was losing negative signs, or, you know, I'd erase and a stray mark would kind of mess me up, stuff like that. So it's good to write bigger and take your time, okay? Transcription errors are very easy to come by here. You know, if you forget to write your negative, right, on this step where I almost forgot to write my negative, that would follow through on the rest of my problem. So negative 2 squared is 4. Negative 3 times negative 2 is a positive 6. Now my 6's here cancel out, so I get 4 to the 3 halves minus 14 equals negative 6. And notice that's the same part as right here. Okay, so I know that this is going to solve out the same way. Alright, so square root of 4 is 2, cube it, you get 8. Okay, and negative 6 equals negative 6. Which I'm just going to squeeze right there at the bottom. So x equals 2 is also a solution. Sorry if my Facebook Messenger's popping through. I thought that I had turned that off. Okay, so then we have one last problem on this one. And oh, Savvas, 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 Savvas. I worked on this problem for about an hour before I got fed up. Well, I shouldn't say an hour, maybe like a half an hour before I got fed up and messaged the smartest person that I know who told me it's impossible. So I want to show you why it's impossible. To do by hand at least. You can do it with a calculator. So we know that to get rid of this weird fraction, you have to raise it to its reciprocal. So I'm raising both sides to the 2/5. So here on the left side, I get x plus 8, and then 2 squared is 4/5. And then on the right-hand side, I get x minus 10. Well, if I raised it to a reciprocal again to try to get rid of that 4/5, that would put a fraction over here. And I just bounce, unfortunately, between the two. All right. Now, I did try a trick to see if it would simplify. What I was trying to do was I said, well, what if instead, I'm going to erase this. I said, what if instead of raising it to the 5/2, what if I called this this square 4/2? Because isn't 4/2 the same thing as 2? And then both of those have a 2 in the bottom, so I could square both sides. But that left me at this point, and you can't do anything with that. And I cussed, and I cussed, and I groaned. Y'all, if Salt Bay wasn't a thing, I would have been Salt Bay. I tell you what, I was so mad. So I just want to show you how to plug it in Desmos and get a answer from the computer, okay? So can every problem be solved by hand? No. And that's okay. So here I've typed the equation in, and it produces this line here. And I thought it was funny because even Desmos won't let you click the line to see what it is. So you could tell it's like just over 27, but you don't know what the heck that is. So what I ended up doing to try to figuring out the problem was I just said y equals 1, and that gave me this horizontal line. And then I tried to find about where it ran into it, which is about right here. And so that's where you get the about 27.3 that I'm putting in for my solution. Let me see if I can print screen this. 1 second. Oh, and then I move my mouse. There we go. But yeah, talk about some frustration right there. So that's where I put it into Desmos, and that's where the answer x is approximately 27.3 is coming from. That is not exact. The actual answer to this goes on for forever. It's an irrational number. Do I know what it is? Nope. But there you have it. So that is how to solve, or approximate in some cases, with rational exponents. Until next time.